binomial array. So binomial array, you have to use the binomial theorem. For binomial theorem, if you have one conductor, that is 1. If you have two conductor, 1 1. If you have 3, 1 1 plus 1 is 2, and side is 1. And again you can extend like this up to any number. 3 here is 1. So only if you have one antenna you have to use. If you have two antenna, this pattern, 3 antenna, this pattern, 4 antenna, this pattern. So like this you can extend. Okay, whatever the number of antenna that you have, the pattern can be created using binomial array. Then this is giving you the magnitude of the current. Say for example, if you have 4 antenna, for the first antenna you have to current of 1 ampere. For the second antenna you have to current of 3 ampere. For third antenna you have to use the current of 3 ampere. For fourth antenna 1 ampere. So in the previous case and all, we are not changing the magnitude of the current, but now here we are changing the magnitude of the current. So in case of binomial array, we are exciting the antennas in such a way that the current is following the binomial array pattern. Once if you excite your antenna in such a way, suppose if I am having antennas like this, if I am exciting with this current pattern, then there will not be any side lobes. Okay, there will not be any side lobes. So to eliminate the side lobe, you have to excite your antenna as per the binomial theorem. So once if you do this, side lobes completely removed. Okay, side lobes completely removed. Okay, here they have not mentioned anything about phase and all. So do not change the phase, only vary the current like this in this manner. Okay, then and again the current is varied as per the binomial theorem. Then finally what will be the, because I am not changing any phase, so definitely my radiation pattern will be like this, because when I am not changing the phase, my radiation pattern is perpendicular to the array axis. This is array axis. Okay, but in this case I am not having any side lobes. In previous case and all, there is a possibility that I may have a side lobes, but here I am not having any side lobes. Actually here and all you will have some side lobes, sir, but I am not mentioning here. You will have some side lobes. Again, not to make a confusion, definitely you will have some side lobes here. Similarly for here also you will have some side lobes. Okay, like this you can join these two, no problem. Okay, you'll have side lobes like this. Okay, but in case of binomial array, you will not have side lobes. That's the main idea. In the exam, they'll ask question like this: to avoid side lobes, what has to be used? Binomial array. Binomial array avoids the side lobes. Next one is smart antenna design. Smart antenna design. With this, I will stop. Okay, with the smart antenna design, I will stop. Okay, later we'll see it on tomorrow. Smart antenna design. So in the beginning, we have started our discussion like the aim of antenna array is to radiate power in any direction that you desire and to get any gain that you want. By increasing number of conductors, you can increase the gain of the antenna, that's okay. But in any direction, because we have discussed the maximum radiation only in two directions, either along the array axis or perpendicular to the array axis. Now I want the radiation pattern in any direction I want. Say for example, if I am having a conductor like this is my array axis. Now I want to get the maximum. If I am here, I need a maximum radiation here. I want a beam like this. So in the previous case, we concentrated the beam either along the axis or exactly perpendicular to the axis of the array. Now I need a maximum radiation in a particular direction other than 0 degree and 90 degree. Then that design is called smart antenna design. That design is called smart antenna design. Same. And again, in this case, what is happening? I am not moving physically. I am not moving the antenna structures, because if I move physically, if I take upward, then I can concentrate here, but that's not my aim. Physically, I'm not moving the antennas. By electrically varying the current and phase of these antennas, I am going to change the direction of maximum radiation. So here, the aim of smart antenna design is vary the direction of maximum radiation pattern electronically. Where is the direction of direction of maximum radiation, vary the direction of maximum radiation electronically, radiation by varying radiation pattern electronically. Okay, electronically varying the current and excitation phase electronically without making any physical adjustment electronically. Okay, so now I assume that I need a maximum radiation at some angle, say theta is equal to 60 degree. You know, at any point of time psi is equal to beta d cos theta plus alpha. So earlier theta is 0 or pi by 2. Now theta is 60 degree. Somebody tell me what is cos 60 degree? 1 by 2, 1 by 2. Okay, and for maximum radiation psi has to be 0. Whatever may be the direction of maximum radiation, if you want to have a maximum radiation, the maxima of the main lobe, then psi has to be 0. Once if psi is 0, okay, psi is 0, then what is alpha? Once if psi is 0, this is beta d divided by 2 and this is alpha, then alpha is equal to minus beta d divided by 2. Then what I have to do? So once if I want to have a phase angle, sorry, maximum direction of radiation in this manner, I have to use current I here also I, but with a phase angle of alpha. Now I have computed what is alpha. That could be of any degree, say minus 10 degree, like that. That could be anything. If it is minus 10 degree, then here I will get minus 20 degree. Okay, that means what? 2 alpha, I2 alpha. What I have to use here? I3 alpha. So I have to progressively increase my phase shift. But what is that alpha that I have computed here? Once if I want to have a maximum radiation theta at 60 degree, definitely my alpha has to be like this. If my theta is of different things, say 30 degree, then you compute the corresponding value, then you fix your alpha, then you apply the phase here progressively, then you'll get the corresponding direction, maximum radiation. That's the idea of the smart antenna design. That's the idea of the smart antenna design. Then finally, within 5 minutes, we'll see why psi is equal to 0 always for maximum. Okay, whenever you want to have a maximum radiation, why always psi is 0? Why psi is 0 for maximum radiation? For maximum radiation direction. Okay. Again, maximum direction radiation is something similar to maxima of the major lobe. Something similar to maxima of the major lobe. Maxima of major lobe. Okay. So finally, your answer is going to be decided by array factor. The array factor value is sin n psi by 2, sin psi by 2. Okay. Few minutes before, okay, we have concluded that this array factor is maximum only when psi is equal to 0. Okay, array factor becomes maximum when psi is equal to 0. Then what happens? Okay, see, this is the when psi is equal to 0, the array factor is maximum. Then in some cases, I am using like this. Say my numerator is maximum. Okay, because I can take, except psi, I can take some other value such that my numerator is maximum. I can also choose a psi in this manner, because instead of 0, I can also choose psi in such a way that numerator is maximum. Okay, when I choose psi in such a way that numerator is maximum, okay, that is called as maxima of the minor lobe. Okay, when I choose the numerator is maximum, okay, but not psi is equal to 0, I have to choose psi in such a manner numerator is maximum. Choose psi in such a way numerator is maximum. Then once if you choose like this, then definitely that will give you some angle. That angle is the direction of the maxima of the minor lobe. Okay, the angle. Okay, then once if you choose psi in this manner, then you will get some theta. Okay, of the minor lobe. Theta is maxima of minor lobe. You will get some angle. That angle is maxima of the minor lobe. Then if I want to have a nulls, because between the lobes, let it be major lobe or minor lobes, between the nulls, between the lobes, you are getting nulls. So if you want to have a nulls, okay, you choose your array factor in such a way your numerator is 0, but denominator is not 0. You choose your psi in such a way your numerator is 0, but denominator is not 0. Choose in such a way numerator is equal to 0 and then denominator not equal to 0, then very clearly 0 by something is 0. Okay, that theta gives the direction of nulls. Now you will get some angle that is the direction of nulls. These answers. So okay, so with this I will stop. Okay, any doubts, sir?